started. Hello, this is Mr. Reynolds, and we're in the chemistry lab. And I've got just a simple one that I want to show you, since we're doing we're doing a little bit more with ionic compounds. Notice the name on this. We're going to be using a blue crystalline compound. And a crystal structure is when water, a lot of times when water gets involved, ionic compounds will make what's called a crystalline structure. And you know, in water, from putting water in the refrigerator ice compartment, and the water freezes into ice, and it actually takes up a little bit more space. You know, if you fill up to water to a certain level, the ice is always above that. Okay. I'm getting some in the blue, copper sulfate, CuSO4. Copper loses 2, the sulfate group gains 2. Okay, so it's basically 1-to-1 matchup. But the name, you got to tell me which copper we're using. If you look on the periodic table, it says copper can be a +1 or it can be a +2. So what we've done in the names of the compounds, we have to say copper, Roman numeral 2, sulfate. We're using copper that loses 2, okay? And old name for that, let's do that one also. It's on the name is on this container here, okay? The name on the container, and like I said, you'll run into these in labs. Some of these things have indefinite shelf life, is what the books say. They don't know how long it's going to last. You're going to come across in the old naming systems. So the Latin name was cuprum. So cupric or cuprous, ic is the higher one. We said copper was +1 or +2 that you see on the periodic table. Higher one gets the ic. So cupric sulfate, okay? So when it said that name on there, I knew, looking up copper, 1 or 2, I knew it was the higher one, copper 2, bonded on sulfate, okay? And in its crystalline form, like I said, it's if you look at a little speck of it, it's going to be a crystal, like a salt crystal or an ice crystal. They'll talk about snow crystals up in the atmosphere. So it's when it takes a particular pattern that you would have seen. I've got this compound out of the way now. I'm going to make sure that I have a test tube clamp that's good and sturdy. Since this metal is easy to bend up, I want to make sure it's good to start with. My container says Pyrex the way it's written. I know it's an older one, so I'm just going to be careful with that. And I've got blue crystal down there, blue crystal, so it's pretty cool. This is just a container of water that you'll see once I rehydrate it. And let's get the Bunsen burner started. Turn on the gas. Let's get the burner lit and adjust the flame, and then we're ready to go. Feel how much gas is coming out. That's pretty good. Light the match. Hand down to the middle of the barrel and up so the hand is out of the way. And we have good flame, and I can reach the ashtray and the gas handle without going through the flame. Got a lot of yellow there. Let's line up this. Let's get as much oxygen coming through as we can. Ooh, there we go. Nice, good burner. Nice, good flame. I'm going to back it off a little bit. It just feels like a little gust of wind, it's going to go out. And this is just too fun not to do. Taking away some oxygen, we get the yellow, a lot of unburned hydrocarbons. Okay, yes, that's fun. Okay, I see the tip of the inner triangle. I don't know if you can see that or not. With some dark in the background, you might be able to see the color of the flame a little bit better. Okay. All right. Now, notice if this is very, very blue, blue, and I'm gonna angle it so that any gases can come out. And you see little vapor stuff forming on the inside of it as the flame heats up the tube. Remember, hot glass looks cold, so I'm not going to be touching any of this. Okay. I'm shaking, it's not moving. Some of that liquid water came out, is making it sticky. Okay, I'm going to move it back and forth and work it around some. You can see some vapor forming on the inside up here as the water's leaving. You can see steam coming out. Again, that should be hot water. See some bubbling in there. Okay, again, I'm not going to face it towards me. I'm going to turn around though. Face the other way. Hot air rises, so the top of this is going to be pretty hot coming out, especially with steam. Steam is, water can get to 100 degrees Celsius when it's coming out. Okay, when it changes, when water's boiling, it's 100 degrees, and that's it. So when steam is coming off, the steam can be, depending on how much it's pressurized, the steam is usually hotter. I just want to see what the color's looking like over there. Be careful not to burn some of this. See, it's a little bit brownish. I'm going to use spatula. I want to move this around since we've got a good grip on this. I'm going to put in this metal test tube rack. Okay, let's try it some more. Actually, turn the tube around some. Try to be careful not to touch the hot part. All right. And let me turn around a little more so that you can see it when I'm handling it. These are good tongs. You test them beforehand. Be ashamed of you doing this, and then the test tube slips out of the clamp and cracks all over. And so that's why you're always testing these clamps beforehand. With other students holding these and maybe not paying that much attention, they can easily bend this metal. Okay? And I've had to throw a lot of them away where where it's supposed to be holding onto the test tube is all bent. So that's when it's going to come slipping out. So you might check that beforehand. Heating this up. And actually that's good enough right now, but if I got all the water out of it, I would just have a white powder. Okay. And what's neat, when you're not using the flame, turn it off. So I'm done with that now. Okay. Now we'll get the water over here. And like I said, this is just H2O. I evaporated a lot of it off. So it went from the blue crystal to more of a whitish powder. Actually, looks like I burnt some. Let's see what happens here. Okay. I'm going to put a couple drops of water back into it. That's why you can tell it's really hot just by the sound of it. Let's give it a little more. Seeing some blue crystals reforming. I had a pretty good amount of that powder starting out. Now, if this were regular glass, it would be shattering. It can be really, really hot, it can be really, really cold, but you can't change its temperature real quick. It can't handle quick changes in temperature. That's why it cracks. That's why if you get a little bitty pebble hitting your windshield and it cracks it, first really, really, really cold day in the winter, that crack just starts to grow. Or if it's a kind of cold day and you have the heater on and the window of the glass is getting really, really hot, that crack is just going to expand real fast. Okay, hopefully I rehydrated some of that. A little bit more. Now it's back to the blue solution. Okay, and I see more of the blue powder in there. I can heat it up some and get that liquid gone. Okay. But it's when it's forming the crystal in the back, you can see some of the crystal pretty good up in the front. I don't want to touch it because it's probably very hot. You can see some crystal forming in there. But with the water present, that's going to make it. That's going to help it to form the crystal. And usually what it says on the chemical containers if you can read this. Okay, add a little bit too much water to it before I end here, and I'm going to evaporate some off. And it's getting hot pretty fast. This is why you face it away from you all the time. That got hot faster. It started boiling sooner than I thought. It could have come spewing out. Always face that opening away from you. If you have partners on the other side of the table, you're not, or other workers in the lab, you're not facing towards them either. Always facing away from anybody. Okay. This would hit the chart behind me. Just going to keep it going gently. Notice how I'm taking it in and out of the flame, controlling the boil on it. Okay. You had to do this some with when you were distilling, but you were adjusting the burner on when it was underneath the distilling flask or not. So that is a cool sound. That's his bubble. Okay, and that's it. Be safe, and we'll see you later. Bye. See you later.